Okay, for this warm up, not being in class, it might be a little tougher to understand. In class I have students, come up to the board and explain their reasoning and go through it a good amount. I do find that the graphical relationship between functions. So if you notice here, these top four are named f, and then the bottom four are f prime. So these are the original functions. These are the derivative functions of the top four. Those in Physics C that already know your shortcuts, you might be a little more likely to know just kind of right away based on the shortcuts, what they are. But I'm going to go through this kind of slowly. And at the end, if after I'm done explaining this, if you're still confused, it's okay. We get a lot into this. We'll get a lot of practice with it. This is just kind of scratching the surface and getting you guys into the thinking of relating a function and the derivative and how we do it. So here's my advice. When I start this out, I can remember back to calculus, and this was the worst thing for me. I couldn't do it, and it wasn't until I started teaching this class that I was like, oh, that's not so bad. And so I'm going to go through this kind of slowly to hopefully make this make sense. But the y values of a derivative function stand for the slopes of the tangent lines of the original function. And here's what I mean by that. So if I look at this first function right here, okay, and I kind of start over here on the left. And I want to think right here, what would the slope of this line be right here at this point? Like, what's the slope of this? And the slope of this, well, the slope of this whole line is 1, right? So at this y value, on f prime, at -3, the y value should be 1, because these y values over here stand for the slopes of the tangent lines of this graph. So right here at -3, the slope is 1. So I go down here and I just think, okay, at -3, which of these has a slope of 1? And that's right here. So I already know the answer, but I'm going to kind of keep explaining this. So then I just move a little bit, closer, maybe at -1. I think, what's the slope right here? Well, the slope right here is also 1. So on this graph's derivative at -1, the slope should be +1 right here. These y values all stand for the slopes of all of these locations. So as I keep going, even over here, when x is 1, the slope is 1. And when x is 3, the slope is 1. And so you can see the slope at every single x value on this graph, the slope is always 1. So the derivative of this graph, the y value, should always be 1. And that's what this is right here. These y values stand for the slopes at all the places along this graph. So that's the basic relationship between a function and its derivative. The derivative y values stand for the slopes of the original function. So I look at 40. And I just think, I start here. I just start at the left and I just kind of go along and just ask myself these questions. I say, self, if I would draw a tangent line here, okay, I just want a rough estimate of what the slope of that line would be. I know it's negative, and it's pretty steep, so it's a big negative number, like -5 or -6. I don't know exactly, but I just want an estimate. The slope right here, when x is -2 or whatever, the slope is like -5 or -4 or something. So I go down here to match, and I just say, okay, at -2, which of these y values down here is negative, like a big negative? So no, that's -1. That one's a little bigger, right here. This point right here, that y value of -3.5 or whatever right here, means on this graph at -2, the slope is about -3.5. And then I just go along the graph. Like, let's go to 1 or something. It doesn't matter where you go, but just to get an estimate. So if I draw the tangent line here, and I think, what's the slope of this? Well, it's still negative, but it's a little less negative, like -1 or something. So I go down to this graph, and when x is -1, the y value is -1. That's standing for the slope of this tangent line right here. That's what we need to associate, is the y values of f prime are the slopes of the tangent lines of f. And then I go right here. Okay, if I draw the tangent line there, it's a horizontal line. Think about what slopes of horizontal lines are. 0. So at 0, f prime, the y value should be 0. Right there. That's standing for the slope of the tangent line. And then when I get on the other side of the y-axis, like right here at 1, and draw a tangent line, well, now the slope is positive. Positive slope. Maybe positive 1. It's going to be the same as this, but on the other side. So when x is 1, notice here, right about here. And then a big positive when we get to the end. A big positive value. So here, we have a big positive value. So I just go along the curve of f and just think, what would those slopes be? And then I just kind of plot or associate those points on the derivative graph. Okay. One of the big things we're going to have to make an association with, and I'll just tell you now, is anywhere a function is decreasing, see how f is decreasing here? All of these slopes, if I draw the tangent lines, will be negative slopes. So anywhere a function is decreasing, then the derivative graph should be negative there. So notice that this graph is decreasing all the way until you get to 0. Notice here, this derivative graph, all these y values are negative until you get to 0. So a big association is where a graph is decreasing, its derivative will be negative. Where f is decreasing, f prime is negative. And same thing on the other side. Where f is increasing, these slopes are all positive. So f prime would be positive. Those are big associations there. And then anywhere we have a horizontal tangent line, f prime is 0. The slope is 0. We got a couple more here. So 41, I just think, what's happening right here? Right after you leave the origin, if I would draw the tangent line to that, it's going to be something really, really steep. It's almost vertical, but not quite vertical. So just to the right of the y-axis, our f prime value should be really big, right up here. So that makes sense. And then as we go along the graph, think about what's happening to our slopes. They're still positive, slope's positive, but it's getting more and more horizontal. Like it's getting closer and closer to 0. So if you look here, all these derivative values are positive, but getting closer and closer to 0. And so that's how we can match this derivative graph up with this function. This function is always increasing, which means its derivative graph should always be positive. And that's what we have here, and getting closer to 0. Then the last one, let's think about what the slopes would be at all these locations. Well, this slope is -1. This slope is -1. This slope is -1. So anywhere to the left of the y-axis, all these slopes are -1. So that's what you have right here. All these f prime values are -1 to the left of the y-axis. And then over here, all +1. All +1. Notice right here, we don't have a derivative value. So those are open circles, which we're going to talk about in the lesson video about why that occurs. But right here, we have no derivative value at that sharp turn right there. If you're like, I have no idea what you're talking about, you're okay at this point. I just wanted to expose you to this and kind of where we are headed. I mean, there will be a time we got to be very good at this, but that time's not right now. We just got to start understanding that these y values are the slopes of these functions here. All right.